Classification, three methods. In our previous few lectures, we were looking into different techniques that are used in classification, right? And we learned about probability theory, we learned about decision theory, and we understood how you want to make use of probability theory and then decision theory in order to make a final choice for classification, right? And we also went through many concepts, different probability concepts that are used in classification. We learned about prior, posterior, and all those things, right? See, the reason why we are going into good depth in all these concepts and we are trying to understand it mathematically, we are trying to understand it graphically, and we are trying to create a complete logical idea of everything in our mind and connect everything so that you will be able to understand everything, visualize everything in your mind once you are dealing with a machine learning problem. The reason why we are doing this is, see, if you want to simply say that I have done a machine learning project, or if you simply want to claim that I know machine learning, it's very easy. You get a lot of project codes from everywhere. You can simply learn one particular project's code from somewhere. That's very easy. But if you actually want a complete hold on the subject, if you want to understand the subject, in that case, you need to have an in-depth idea of what happens behind each method. Let's say you are having a machine learning model, you gave some input, you got some output, but you need to understand what all happens inside this model so as to be confident on the topic. And more than everything else, you should be able to identify why you are using one particular method, or why is this particular method the best for the problem you are dealing with. And when you're using this method, what all things happens behind, right? You need to understand that. And once you are preparing about a model, you should know what all modification you can make on that model, and if any innovation that you can bring on your own into the field of machine learning. That's the ultimate aim. So whenever we are going through any topic, we'll try to understand it from all these perspectives so that you develop all this idea. You develop the mathematical understanding that goes behind, you develop a graphical understanding, you get conceptual understanding, and you are able to visualize everything. So that is why we are going into deep. Okay. So in this particular lecture, what we are going to do is, whenever you get a classification problem, let's say someone asked you to solve a classification problem, you should know that these are the approaches that I can take. That is at least the major options that you have, 1, 2, 3. So which one you should choose and why you should choose on any particular case. Okay, that is what we are trying to understand in this particular lecture. So the first thing, our approach 1. Okay, we are going to see for the approach 1. This is our first approach today. That is, see, in a classification problem, you have an inference stage and then a decision stage. So in inference stage, you make your model learn, you train the model so that when you give some input X, it will give some output Y. Okay, this is your inference stage. And once in your inference stage, you get this Y, what is your decision stage? Decision stage is using whatever your model told you, whatever you got from your inference stage, you want to classify this X into one class. Let's say you have C1, C2, C3, multiple classes. Okay. So from the input X, how you finally reach one among these three classes, need not be three, whatever be the number of classes, how do you identify one particular class? That is all about classification. Okay, so we'll see what you should do in inference stage in each of the approaches, and then what you should do in decision stage in each of the approaches. Okay, so our first approach. In the first approach, what is your inference problem? Your inference problem is determining the class conditional densities. What is class conditional density? If you have your input is X, then your class conditional density is probability of X given Ck. Given that the class is this particular class, what is the probability of X? This is your class conditional density. So identifying the class conditional density for each of the class, right? For each Ck, for each class Ck, you have to identify class conditional density. This is your first task. Your inference problem is this in your first approach. In this approach, the first thing you do is find class conditional densities. Then you have to find prior. We said in order to apply Bayes theorem, you will need prior probability. Prior is what you fix beforehand. That is, before seeing the data, you want to fix a prior. So what is the prior that you will have? For each of the class, you will have a prior probability of class. That is, this may come from your subject knowledge. For example, you know about these three classes that are to be finally reached into. So your subject knowledge may tell you that in general, maybe class C1, the probability of this class C1 is maybe 50%. Class C2 is 20%. Class C3 is 30%. So this is your prior knowledge about the subject. Otherwise, what you can do is from the data that you are having, you can see the split. That is among the total data, data that you have, how much of this data is of class C1, of C2, of C3. Okay, from the training data. From this also you can derive the prior probabilities. So once you have the class conditional densities and then you have the prior probabilities, what do you want to do? You want to find the posterior, right? How do you find posterior? Using Bayes theorem. So posterior is like this. Posterior is, we learned about posterior in the previous lectures. Still I am stating it again. P of Ck given x, that is given the data x, what is the probability of class Ck, that is posterior. This is equal to, here we are applying Bayes theorem, class conditional density P of x given Ck into your prior P of Ck whole divided by P of x. What is P of x? It is the marginal density, right? So here, and let me tell you, this particular approach 1, this is the most complex approach, most difficult approach. But at the same time, if you use this approach 1, you will have complete idea of this problem. You will get end-to-end idea of this problem, and you will be able to do any sort of modifications on this. So firstly you found class conditional probabilities, then you found the prior P of Ck, then you found the posterior P of Ck given x. So finally posterior is the most important part that you want to find. Once you find the posterior, what is the next thing? Once you find the posterior, the last step is to identify the class. How do you identify the class? Once you know the posterior, you use decision theory to say that if this is my posterior, then looking at this, I will decide that I will put this into class C1, C2 or C3, whatever it be. So sometimes if you want to simply minimize misclassification, simply depending on whichever has the highest posterior, you will assign it into that class. Otherwise, maybe you will apply some other logic as well, and you decide that if this is the posterior and these are the conditions, then accordingly I will put into some particular class. So that is the part of your decision theory. And these sort of models which use this approach 1, that is, they first find out the class conditional densities, then they find out posterior, and from the posterior they find final decision using decision theory. These sort of models, these are called as generative models. Okay, generative models. Why are these called generative models? Just give a thought. Why are these models called as generative models? The reason is simple. See, when you're finding this, you are finding this particular quantity. What is this? What is P of x? P of x is your, what is this called? P of x. This is your marginal density. So what is the advantage that you get with your marginal density? See, in order to find P of x, you can simply do this. That is, for marginal density, we have seen that in order to find this, you can just sum over all the values of k, right? P of x given Ck into P of Ck. If you do this, you will get the marginal density, right? If you get this marginal density, the idea is that now you know the distribution of input. See, you wanted to find the output, but with this marginal density, what you found out is the distribution of input. Let's say your input is distributed like this. This is your x, this is probability. So now you know the distribution of your input, P of x. Because you know the distribution of input, what special capability do you have now? You can create new input points as per your wish. So this ability to create new input points, to generate new synthetic data, this ability you will get only if you know the marginal densities. And once you know that, you can generate new input points. That is, let's say you're presently given some amount of data, you can generate new input points. That is, the model distribution of input, it is known to you, and using that you can generate new input points. Hence it is called as generative models, right? So once you have a generative model, the whole thing is that now you have complete hold on this problem. You can do everything from generating input, finding class conditional probabilities, finding posterior, and then assigning it into class. Whatever, you can play around with this model. So this is the most complex approach. This is a very difficult approach, but if this is the one you are following, then you have these particular advantages. That is, you will be creating generative models. These are what you call as generative models. Remember this. Now let's go to next approach. Next one is our approach 2. Approach 2. So what is our second approach? In this, your inference problem, previously you tried to find class conditional densities, then you tried to find corresponding posterior. From that, you also found the marginal densities, that is P of X, from which you were able to generate new points. So in the second approach, you are more going towards a classification approach instead of finding all these marginal densities and all. What are you doing? Your inference problem is directly finding the posterior, that is P of Ck given X. Finding the posterior is this time your inference problem. So you are not going to find the class conditional densities. You are not going to find marginal densities. You're not going to do any of this. Okay. This time you are simply, your inference problem is directly finding the posterior probability. So once you find the posterior, what you will do, you will use the decision theory. Using decision theory, you can assign this into one particular class, C1, C2, C3, whichever class you want to do. That part is same. Okay. So these sort of models which are not capable of generating any new synthetic data because you don't know marginal density now, but this is good enough for classification, right? You can identify which class it belongs to. So for classification, this model works. It is not as complex as the previous one, okay? And it is good for classification, for any sort of classification task. Moreover, we'll come to know in the coming lectures that knowing this posterior itself is a big thing in a classification problem. From this, you can get a lot of information. So these sort of models which infer posterior and from that make the final decision, these are called as discriminative models. Okay, discriminative models. So why are these called discriminative models? These are able to identify the correct class because it finds the posterior, and these sort of models that model the posterior probabilities directly, these are called as discriminative models. So till now we found generative models and the discriminative models. Discriminative model is a second approach. Then there is a third approach. See, we are going from toughest complexity approach towards the easier approaches. Okay, so the third approach is the easiest, but when you are going to solve a problem, you need to see all the dimensions and which one you want to apply. So the approach third, what is a third approach? In this, see, in the first approach, first we found the class conditional densities. We found X given Ck. Then from that we found the marginal density. Then we used it to find posterior, Ck given X. Then we used decision theory and found the final answer. In the second approach, we removed all these steps. Inference problem was directly finding the posterior, P of Ck given X. And from posterior, you used decision theory to reach the final class. What is the third approach? This time, you are making it even simpler. You are not going to find class conditional density. You're not going to find marginal density. You're not going to find posterior, nothing. What you're going to do, you have a excess input. From this, you're going to simply model a function, f of x. What will this function do? This function will directly map x into one among the classes C1, C2, C3. So this is the simplest approach for classification. That is, when you're making a model, this is your model. What will this model do? It will take x as input and directly it will transform x into classes C1, C2, C3. Okay. So this time the disadvantage is you don't know any of the component probabilities. You don't know posterior or anything. You simply know class. Okay. So here what you will do is you will have some class label. So if you have C1 and C2, let's say, or you may have C3 as well, then if f of x equal to 0, then you will say this is class C1. If f of x equal to 1, then you will say it is class C2. If f of x equal to 2, you will say it is class C3. So this is the simplest approach. The point here is here probabilities do not have any role. Here it is a kind of black box in which you have x as input. You prepare a function. This function will directly give you C1, C2 or C3. So in the next lecture, we will analyze these three approaches and we will see what advantage do you get when you go for the larger approach, complex approach. What with that information, what all you can do and what you disadvantage you get when you use a simpler approach. Okay. As of now, you understood there are three approaches. You have to choose one among these if you are modeling a classification model.